Hello, class. And so I'm going to do a very brief overview of what we did yesterday. And so here we go. I'm going to begin with some notes that we took yesterday. So if you noticed on the side of the board, one of the things that I did do was I had the unit circle set aside with, their major quadrantal angles. We have the 0 degrees 2 pi to start with, and then we go counterclockwise to pi over 2, counterclockwise further 1 more quarter to pi, going further 1 more time to 270 at 3 pi over 2, and then we end again at 2 pi. And I also have written for you the 4 points that we use as a guideline for X and Y values on the unit circle. So what I want to draw is the connection between these two. So we start with Y equals 1/2 sine X as the graph that we started with yesterday. And we're graphing the values from 0 to 2 pi. So how do we do this if we don't have technology and we just have paper and pencil? So the first thing you're going to start with is what's in yellow, which is the amplitude. You're taking the absolute value of that amplitude, which is 1/2, which means that Y as a range will be from Y equals 1/2 to Y equals negative 1/2. The period, as we locate this one, this is a period of 1 because it's just sine X. So the rule of thumb is we take the period divided by 4. And so since sine has a period of 2 pi, we're going to take 2 pi divided by 4, and that gives us pi over 2. So right now in the notes, I am at this point right here, where we have our value. And so we then take our formula. So if you notice, I have basically taken a header right here where I have an X value, the equation itself, and then the resulting coordinate point that we're going to graph. And so we start with X is 1. This is like our X1, which is X is 0. So we substitute that into our equation and we get Y equals 1/2 sine 0. Well, 1/2 times 0 is 0, and we know that, which is our starting point right here. You see how I have 1, 0? The 0 is the Y value. And so our first coordinate actually ends up being 0, 0, because we start with 0, which means X is 0, Y is 0. We then go further, because remember x2 is the result of 0 plus 1 pi over 2, which is pi over 2. So we substitute in sine of pi over 2. Well, sine pi over 2 goes this way. All right, and if you remember, our starting coordinate X and Y point is 0, 1. So that means that I have 1/2 times 1, because this is 1. So 1/2 times 1 is 1/2. So my coordinate point then becomes pi over 2, comma 1/2 for this function. Our x3 is the result of pi over 2 plus pi over 2, which is just pi. And so if we substitute in 1/2 sine pi, so we'll multiply sine pi, which is 1/2 times 0, because our coordinate y is 0. Giving us our third coordinate point, pi comma 0. X4 is nothing more than the result of pi plus pi over 2. Again, once again, we're still adding pi over 2, and that gives us 3 pi over 2, which is our 270, where y is negative 1. So 1/2 times negative 1, which I wrote here, looks like a negative something something. I don't know quite what it is. So 1/2 times negative 1 is negative 1/2. And so this gives us our fourth coordinate point. So if you notice, the resulting value is now our x. We're substituting that x in here and then working it out. This is our x value, and this is the resulting y. And lastly, our fifth point, our critical point that we're looking for is 3 pi over 2 plus pi over 2 gives us 4 pi over 2, which is 2 pi. And we know 2 pi is also has a y coordinate of 0, right? Because we're here. And so therefore, when x is 2 pi, y is 0. Okay, again, for the sake of the example, I'm going to one more time show you in GeoGebra, which you should learn to love. It's a wonderful tool. So I'm going to go here into GeoGebra. Classic. I like Classic. It's the best of all their programs to date. Other programs are a little bit antiquated, and I'll tell you why I like it. You notice how immediately I have all the tools right here? That's the blessing. So yeah. So anyway, 1/2 sine x. Only one period. I'm only asking you to graph this from 2 pi, 0 to 2 pi. So just for the sake of the example, let me do this for you. I want to make two things very clear before I start graphing any points. First of all, we're starting from x equals 0 to x equals 2 pi. That's the only area I'm looking at right now. As far as the range, because remember, that's the domain. As far as the range, I have y equals positive 1/2. And on the downside, I have y equals negative 1/2. So if that's helpful to you. Right now, the only area you're focused on is here through here. That's it, 0 to 2 pi. So you start punching in the coordinate points. So here's 0, 0. The next point is going to be, as we calculated, was pi over 2. See, and I want to do this on purpose because you notice there are no parentheses. Do you see a point up here? No. Go back to scratch, parentheses. Pi divided by 2, scooch over, comma, 1/2. Now you see the point up here? And that's what we want. The next point we calculated already was the point where we're intersecting the axis, which is just pi, comma, and of course, 0. Okay, so that's our point C. The next point was our 270, right? So then this would be 3 pi divided by 2, scooch, comma, and then we want -1 in this case, or negative 1/2. Again, do you see a point? No, because if you don't have parentheses, it doesn't recognize it as a point. It recognizes it as jargon. So 3 pi divided by 2, scooch over, comma, -1/2. All right. And the last point which we need is parentheses. We need 2 pi, comma, and 0. And there you go. That's all the points. So if I was to right click on this, I can go to settings, which I want to show you. You want to go to basic and you want to go to name and value, because I've asked you that I would want to see this, because this is how we determine if you were correct or not. If I want to change the color, I go to color. Let's make it red. The other thing you can change is the style. So do you like a thick point? I like a thicker point than a thinner point, but there are also other types of things you can do. If you want to do these little symbols instead. They're very hard to read, but doesn't matter to me. Advanced, in case you have issues with too many decimals or what have you. If, by the way, if you do have too many decimals and you want to change it to 1 decimal, there you go. I clicked on I guess the settings button. And so this is what this graph looks like. So you can, again, go to basic, you can make sure you show the label, name and label. Same thing here, go to basic, settings, show the name and label. Change the color. Go back, let's say I wanted to go back here, I want to change the color. I just need to make sure that it's highlighted while I'm doing the actual change. See how I'm able to just pop over. Again, I definitely want to go back to basics. I want this to be name and color. Same thing here, I want the name. I want the name to be in value, with the value. I also want it to be legible. So this is a really cool tool. You're going to see this in graduate school, I guarantee you, especially if those of you who may want to go into like some sort of like calculus or engineering thing with you'll need calculus. I know that I teach this for the graduate students and we use this for modeling calculus questions, which is really good. All right, so there's your interval. This is what would be on graph paper if I ask you for the graph paper, which I will at the end of the lesson. Okay, example 2. Now this one, I asked you to go from negative pi to 3 pi. We're still in sine, so it's still a period of pi over 2, right? So because 2 pi over 4 gives us pi over 2. That's how I got this. Because remember, for sine, the period is always 2 pi, so 2 pi, the period divided by 4. This will result in pi over 2. That's it. All right, and same thing goes here. We're going to use our values. We start at 0, 0, then 0 plus pi over 2 results in pi over 2. We pop in our value. Remember, this is a sine of 90 degrees. Sine of 90 degrees is positive 1. Negative 2 times positive 1 is how I get this. So remember, again, we're going back to the unit circle. Go back to that foundation concept that if there's a point P here, originally that point P will be the value 0, 1. Just like this value here for this point will be 1, 0. This is our 0 and 2 pi, right? This is our pi over 2. Over here we have pi, which we know that if I have a point here, this is negative 1, 0. And if I have a point here, I also know that this point is 0, negative 1. And this is our 3 pi over 2. All right. The next value would be pi over 2 plus pi. I'm sorry, pi over 2 plus pi over 2, right? Because it's the previous one plus pi over 2, always. This is like your x1, this is like your x2 here. This is like your x3. This is your x4. And this is your x5. So that's how I end up with pi for this one, for example. 2 pi's will give me pi over 2 as an added value will give me pi. And here I have pi plus pi over 2, which results in 2 pi, or 3 pi over 2. And 3 pi over 2 plus the pi over 2 gives me 4 pi over 2, which is 2 pi. All right, so let's look at this in GeoGebra as well. This is the negative 2 sine x. Okay, so let me go to File, New, don't save. Okay, so negative, you will save it. I don't save it. Okay, so just for the record. So there's your negative 2 sine x. And now notice that in this one, I'm asking you for values where, so for example, I'm starting at x equals negative pi, all the way through x equals 3 pi. I love that. X equals 3 pi. So I'm looking at this range from here to here. All right, and so if you click on the line itself, I believe sometimes the dots will appear, but all right. So our first coordinate point, negative pi, comma 0. Our next point, negative pi over 2, comma, negative 2. I'm sorry, positive 2. Our next point will be 0, 0. Our next point after that will be parentheses pi over 2, comma, negative 2. Our next point after that, because remember, I'm adding pi over 2, so that'll actually be parentheses pi, comma 0. All right. Our next point is going to be, that's pi over 2. The next point will be 3 pi. So 3 pi over 2, comma 2. Our next point will be the 2 pi, comma 0. Okay, and the following point, I know we're going to end up 3 pi. Let me just do this one, 3 pi, comma 0. Okay. First part of your challenge, find for me the value of this point here where I'm pointing with the cursor. Tell me what point that's going to be. What is the value of this point? So you find it. So this is your quiz question, one of your quiz questions. Right here, find this point. All right, so I'm just going to move this around so you don't necessarily know anything, just making sure you understand that's the point. I just want the number. What is the magic number of this point? I know what the bottom coordinate is going to be, but what is the x coordinate? Okay, next point of the notes. So once you graph that, and I want you to show me that value using this method, okay? Meaning adding positive x over 2. Okay, question number 3. In question number 3, I'm asking you to graph using the value of a sine bx, determine the amplitude and period of y equals 3 sine 2x. I walk you through this, understand that the absolute value of 3 is 3, so y will equal 3 and y will equal negative 3. So that's the top and bottom of the amplitude. For a period, if you notice in red, it's a 2x. So you have a period of 2. So I have basically 2 pi over 4, which is the period itself becomes pi because the 2's will cancel, then it's pi over 4. So we start with 0. 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is just pi over 2. Pi over 2 plus pi over 4 gives me 3 pi over 4. 3 pi over 4 plus pi over 4 ends up in 4 pi over 4, which is just pi. You plug the values into the equation, starting with 0. You solve for the coordinates. Just remember the unit circle and its values. Okay, so this gives us the following. So if I have 0, I have y equals 3 times 0. Or excuse me, 3 times sine 0. And I know sine 0 is 0. So by corner points are 0, 0. If I pop in pi over 4, I have y equals 3 sine 2 times pi over 4, which reduces to sine pi over 2, which is 1. Hence 3 times 1 is 3. Again, go back to the unit circle. Y equals 3 times sine 2 times pi over 2. That gives me pi over 2. The sine of 2 times 0 is 0. So 0. Because this ends up being 3 times sine pi, right? Sine pi is where 180 is at 0. Okay, the fourth point where y equals 3 sine 2 times 3 pi over 4 becomes basically -1 for y. And that times 3 is -3. So we end up with 3 pi over 4, comma, -3. And lastly, where we start with pi, y equals 3 sine of 2 pi. 3 sine of 2 pi is 0. So hence, we end up with pi comma 0. Let me show you this one on the graph. So I'm going to go to sine and go to new. So this is called quiz question 1. I'm going to save that one. And I'm going to go to file new. So, where was I? This is 3 sine 2x. So let me go to 3 sine 2x. Okay, there's your graph. And I'm asking you to start this at x equals negative pi. That point. And I'm also asking you to graph this at x equals 3 pi. I also want you to note and make it a point, not only to find all the intervals, I also would like for you to find the range where y equals, in this case, +3. We also have y equals -3. All right. All right. So there we are. You're going to find the points for all of these. You already have on paper. And then explain to me why it is that this has, in essence, I have periods. How many do we have? We have 1, we have, looks like 2, and 3, and 4. Why is it that this says we have 2 periods, but yet I have 4 cycles of this? Explain that to me in a little paragraph. That's part of, yes, quiz question 2, in a sense. All right, and your quiz question 4, your final quiz question, is this. Determine the amplitude and period of y equals 2 sine 1/2 x. Then graph the function for the range from 0 to 8 pi. I want you to graph it in GeoGebra. You're going to give this file the name February 8th quiz. The second part of the assignment is, not only are you going to do this graph in GeoGebra, I also want it on graph paper. I'll collect this as soon as I see you. That may be as early as tomorrow, or it may be Monday. I don't know. I don't know yet. So that's your quiz, the last part of the quiz. I'm going to stop the recording right now.